Hi, welcome to this tutorial on processing. So, what is processing? So, processing is an open source project that was initiated by Casey Reyes and Ben Fry from MIT Media Lab, and it's been gaining a lot of importance over the recent years. It is a programming language which was developed for electronic art and visual design communities, basically for non-engineers, and it also is built upon the graphical capabilities of Java. It processing also has its own IDE, which is Integrated Development Environment, and which is very similar to Arduino. So here we show the processing IDE. As you can see, there are it is similar to the Arduino IDE, with very few command buttons, and the explanation of these are given here. So here you have your compile or the run button, then you have your stop button, new, open, save buttons, export. It is also possible to export a processing sketch to a standalone application, or to a Java applet which runs on a web page. And then you also have your code window. You have your message bar here, followed by the console, which pretty much gives you the output in the compilation sequences, etc. So before we go into the actual the syntax of the language, we will need to understand what are the different types of or data types which are actually supported by processing. So we have byte, integers, floats, boolean, characters or char, and colors that are supported by processing. So as you can see that these are the value ranges of the respective data types, and the memory requirements of each data type. So typically an identifier, when you actually write a program, a processing sketch, an identifier is nothing but a name. So it could be a function name, or it could be an argument or a variable name, etc. It must be a letter. It can start with an underscore, and it can also start with a dollar sign. Other operations or symbols are not prohibited. You cannot start your identifier with other operations or symbols. Those identifiers are case sensitive, and whenever you are trying to write a sketch, make sure that you are not having an identifier which is of a reserved word. So it's important that you learn what the reserved words are, and so therefore we don't use the reserved words. So we have a function name. Sometimes the function name can have an argument. The function name can also return a value. Sometimes it doesn't need to return a value, so we will call those type of functions as void functions. A function which has to return let's say in a value, is shown here, where we have a cos, which is a function, angle is an argument, and it is multiplied by a factor r. And so when you call this function, which is cos angle, that returns a float or a double or an integer, which is then multiplied by r, and then is substituted to x. So these are some of the examples of the function. So size, background, cos, circle area. So these are all different syntaxes of the function. And before we use the function, we need to define the function. So the function, as you can see, this is your function name, followed by the arguments. If so, in this case, it has an argument which is float r. So r is a variable, and whenever you call for this function circle area, it is going to return a float, and that float, or that particular of type float, is going to be the area of circle. So if I give, for example, I want to find out the area of 3 um, units, and so what's going to be here is this function is going to be called. So 3 is going to be substituted here, which is 3 is a variable times 3 pi. So this is nothing but the area, which is pi r squared, and then this line here says that the area, which is the calculated value of our area for a circle of radius 3, is returned to the function and can be stored and processed, etc. So whenever we talk about variables, there are two different types of variables. We have what we call as local variables and global variables. So in this processing sketch, you can see that we have a global variable because it is defined outside the setup and the draw modules. Again, in processing, you have two distinct modules. We have the setup and the draw. So in Arduino, it is similar. We have the setup function, and then we have the loop function. So in this case, it will be the setup and the draw function. So if any variable is declared outside these functions, they are called global variables, and the value of x remains 5 unless and otherwise changed. So here you can see that we have a setup function. We are declaring a local variable, which is y is equal to 6, and now we change our global variable value to 7, and when we actually print out or use this, so the value of x is equal to 7. But once we step out of the setup, and in this case you can see when you go to draw and you start to execute this line, which is print line x, so the value of x will be reflected of the global value, not of the value which is here, because this is what we mean by a local variable. The scope of this variable x is defined to this function only. So as we said earlier, every processing application has got basically two modules. We have the setup and the draw. In the setup function, as you can see, we generally tend to describe the size of our application. So we need a window size of 200 by 200 pixel, and also we tend to specify the frame rate in which you want to refresh your screen. So here the frame rate is given as 30 frames per second, and the print command just says that the setup is all being done, and the draw will try to print high repeatedly. So therefore you need these two components, which is setup and draw. So we go to our first application. So here, as I said, our first application tries to draw an ellipse, or in fact a circle, and tries to expand the circle, and once it goes out of scope of your window, it then goes back to 0. So what you get is like an animation effect, that a circle getting larger, and then once it reaches the boundaries, it then starts back again from the center and then gets bigger and so on. So as you can see, we have first set up our size of our window application, which is 300 pixels by 300 pixels. Now we want to draw. The draw function says I want to increment my value of x, so x becomes equal to 2 here because x was initialized to 0. And now I have my ellipse function called, and 150 comma 150, that specifies the center. What do you want the center of the ellipse to be? And x comma x is nothing but the a and the b function. So if I use both of them as the same value, then my ellipse becomes a circle. And now I have if again, if x is greater than 300, as we know we have already touched the boundaries, then we restart again back to 0. So our ellipse becomes really small and then gets back again in increments in size. So here is our compilation sequence. As you can see, so a compilation is simply to press this run button, and this is what we meant that we are drawing circles using the ellipse function, because x is equal a is equal to x and x. So the function, the circle gets bigger and bigger when x is equal to 300. As you can see, we start again to redraw the circle again. So there are also other objects you can draw. So as you can see, you can draw a rectangle. So this specifies the center of the rectangle, and the parameters here are your length and your width. So this becomes a square. This is the function which we already saw, the ellipse. We can also draw lines. We can also add colors or fills to a particular object that we draw. So here you can see that we can specify a color. So this is given as an RGB component, and we are trying to do a fill of C, which means that you want the color to be filled for this rectangle, which starts with an origin which is 0, 0, the center, and then it has a length and a width. So when you draw also lines, you can introduce strokes. So again, you can specify the color of the strokes, the weight of the strokes, and again the line. Okay. Again, you can draw curves. You can start at a particular value, x value, y value, and then you can reach at a particular value. So you can draw curves. You can define vertex. So usually what happens is, as in the previous case, say this example, like let's say we want to draw a box or a cube, or let's say even if you want to draw simply a square, but you want to give it a particular color, say red. So therefore it involves a sequence of these basic draw objects. So you need to first implement or define your color you want to do, the fill, and the rectangle. And so these three can be treated as defining a red color box. So whenever you want to club these components together, therefore then you can actually use shapes, like you can define begin shape and then give these three statements, which is defining of the color, and then define even for example your strokes or the thickness of your strokes, and then define the shape and the rectangle, the size of the rectangle or the square, and then followed by end shape. So therefore you can create customized shapes like a red box. It is also possible to use text in processing applications. You can create your own text, or append text, or narrate text into or superimpose text into any application which you develop. So therefore you can use any particular font you want. As you can see here, we are going to use SPF font Arial. So, and then we try to create a font, and you can use a text font. Here we are trying to use of size 15. So it's also possible to use any fancy fonts to create artwork. The most important thing about processing is its ease to actually capture mouse movements. So there are a lot of variables that determine the position of the mouse. So we have a mouse X variable and a mouse Y variable, which defines the current location of your mouse. There is also other methods like mouse pressed, which detects or which pretty much evokes an event or an application in the event of a mouse being pressed. Similarly, if you have something like, you also have functions like mouse released, so what you want the processing to do when the mouse is actually released, and a mouse is dragged. Well, if I want to drag from one point to another, so if the mouse is being dragged, what do you want it to do? So these are all functions which are very useful to create animations and to create very interactive applications using processing. It is also possible to do very powerful image processing applications, very simple, and also video. You can actually create videos, you can actually play videos, you can actually edit videos even using processing. And similarly, also with images, you can do different type of morphings and filtering, and even very advanced image processing applications like people detection, blogging, blog detection, and so on and so forth. Later on we will see some applications of image processing. So here is some of the sample codes which are given for image and video processing. And so this is simply an application which just loads an image. So um, we're taking a JPEG image and you're going to use processing to load that image. So here again on your right hand side is another application which is taking the image and then trying to determine what is the width and the height of the image, and then goes through the pixels, every pixel of the image, and then tries to every alternate pixel it tries to color it white. So and then it updates the image and displays the image. So as you can see, this few lines of code can read the image, process it, and then update the image and store it. So image processing is really simple in processing. Here again is an application where you can play a movie. It's another important thing in processing is reading and writing files. So we use load string function to actually read um, lines or words from a particular file. And similarly, if you also want to create or write back to a file, we can actually use the save string option, which creates it to or creates a file. There are many functions which can be used along with processing. So I would recommend that you go to dev.processing.org/reference/core to have a complete look at the different functions that are supported by processing. For computer science majors and computer science students, we see that processing also allows a, a variety of storage and computational data structures and data types. So here is an example of an array, and computer science people with very limited C or programming knowledge can see how similar this syntax is with respect to C or C++ or Java. They also processing also supports useful data structures like stacks, queues, advanced data structures like sets, lists, trees, and graphs are also supported. There are a lot of libraries which are available, and obviously string is also part of the data structure. So this gives you a variety of data structures to implement very high level computer science applications. We can also create classes and objects. Classes are nothing but a collection of all related objects. It's called a class, and whenever we define a class, we define the properties of the class, and then we define the constructors of the class, and we then define what do we want to do with respect to uh, the functions or the methods of the class. So processing also allows you to actually develop your own classes and objects, etc. So based on this, as you can see, for computer science folks, it allows support for advanced data types. There are a lot of libraries available for artificial intelligence, genetic algorithms, automata theory, animation, image processing, 3D rendering, geometry. So pretty much, all aspects of the computer science can be implemented or be done with processing. Processing also allows for the control of NXT controllers, which are very commonly used by mechanical engineering and civil engineering folks. So as you can see, there is an NXT-COM library, which allows you to control our NXT controller from processing. There is also a bunch of control libraries available. The most common one is the Control P5 library, which allows you to actually use or develop very interactive applications like control applications or control GUI, like the ones you find in LabVIEW or the ones you find in MATLAB, Simulink. So these control library, which is called Control P5, gives you libraries to create sliders, knobs, and other type of user interface controls. And with respect to the NXT-COM library, it can also communicate with a controller using Bluetooth as well as the USB. So the next section we will see is processing by examples.